Introduction: traditional internet connections rely on centralized infrastructures and service providers. In contrast, mesh networks present an entirely different model of communication, one where devices directly connect with one another to relay data without needing a central router. This technology can bring the concept of an internet without the internet to life, especially in scenarios where conventional connectivity is lacking or disrupted. But what exactly are mesh networks, how do they work, and what do we mean by internet without the internet? In this video, you will find a comprehensive exploration of the technical details, real-world examples, and the advantages and disadvantages of mesh networks. The fundamentals of mesh networks. 1.1 Definition and basic principles. A mesh network is a system where devices, nodes, are connected directly to each other, with data transmitted among them automatically via the best available path. Unlike traditional networks, which depend on a central server or router, every node in a mesh network both sends and receives data simultaneously. This structure makes the network more flexible, resilient, and scalable. The core principles of mesh networks are: 1. Distributed architecture. Every node works as an equal part of the network. 1. Without a central control point, the failure of one node does not bring the entire network down. 2. Automatic routing. Mesh networks use dynamic routing algorithms to automatically route data via the most optimal path. 2. If one node goes offline, data can still be transmitted through alternative routes. 3. Self-healing. Any disruptions or node losses are compensated for as other devices form new connections. 3. This is especially advantageous in emergency situations or areas with limited infrastructure. 1.2 The concept of internet without the internet. The term internet without the internet refers to the ability of mesh networks to provide communication capabilities in situations where traditional internet access is unavailable or severely limited. This might occur during natural disasters, conflicts, or in remote regions where centralized internet connectivity is absent. With mesh networks, devices communicate directly, sharing data without reliance on centralized servers. 2. The technical operation of mesh networks. 2.1 Routing protocols and algorithms. Efficient data transmission in mesh networks depends on robust routing protocols. Some of the most commonly used routing protocols include: 1. OLSR, Optimized Link State Routing. This protocol shares state information between nodes to determine the best routes. 1. It is highly efficient in dynamic networks with frequent updates. 2. PATMAN, Better Approach to Mobile Ad Hoc Networking. This protocol assesses the quality of links between nodes to choose the optimal path, particularly effective in mobile or rapidly changing environments. 3. DSR, Dynamic Source Routing. In networks with numerous nodes, this protocol dynamically determines routes from the source to the destination, ensuring continuous communication. These algorithms enable mesh networks to be flexible and self-renewing. Data is automatically routed along the best available path among nodes, eliminating the need for a central server. 2.2 Hardware and software requirements. Mesh networks typically use devices that operate on Wi-Fi or radio frequencies. Smartphones, laptops, IoT devices, and even some specialized hardware can all become part of a mesh network. On the software side, open-source operating systems like OpenWRT, which implement network management and routing protocols, ensure that nodes can communicate seamlessly and transmit data efficiently. 3. Application examples of mesh networks. 3.1 Use in natural disasters and emergency situations. During natural disasters, communication infrastructure may be severely damaged or completely disabled. In such scenarios, mesh networks can be life-saving. For instance, in the aftermath of events like earthquakes, floods, or storms, emergency response teams and rescue organizations can use mesh networks to communicate and coordinate their efforts. A real-world example is the temporary mesh networks established after the 2017 hurricanes in the Caribbean, which helped restore communication and facilitate rescue operations. 3.2 Communication in rural and underserved areas. Mesh networks offer an economical and effective solution for providing internet access in rural and underserved regions. In parts of Africa, for example, low-cost mesh networks have been deployed to connect local communities, enhancing access to education, healthcare, and digital information. These projects not only boost local economies but also help bridge the digital divide. 3.3 Military and security applications. In military operations, the decentralization of mesh networks is highly valued. In conflict zones, where centralized communication systems might be targeted, mesh networks allow military units to communicate continuously even if some nodes are compromised. Additionally, security forces use mesh networks in densely populated areas to ensure uninterrupted communication. 3.4 Mesh networks and smart cities. Mesh networks play a crucial role in smart city projects. Sensors, cameras, and IoT devices distributed throughout a city can connect via a mesh network to optimize urban infrastructure. This technology can improve traffic management, energy distribution, environmental monitoring, and public safety, providing significant advantages to city management. 4. Advantages, disadvantages, and future prospects of mesh networks. 4.1 Advantages. 1. Resilience. Without dependence on a central server, the failure of a single node does not disrupt the entire network. 2. Flexibility. New nodes can be added easily, enabling the network to grow naturally. 3. Cost-effectiveness. Especially in rural or infrastructure-poor areas, mesh networks can be built using low-cost devices. 4. Security. With no centralized target for attacks, mesh networks can be more resistant to certain types of cyber threats. 4.2 Disadvantages. 1. Data speed and capacity. The data transmission speed and capacity of mesh networks can be lower compared to centralized networks. 2. Routing complexity. In large mesh networks with numerous nodes, dynamically determining the optimal data path can become complex. 3. Security risks. The distributed nature can potentially allow unauthorized access if robust encryption and security protocols are not implemented. 4.3 Future expectations. As technology continues to advance, mesh networks are expected to play an increasingly important role. With the rise of 5G and the proliferation of IoT devices, mesh networks may become integral to large-scale data transmission and smart city applications. In the future, mesh networks could prove vital in providing internet without the internet during natural disasters, wars, or in areas lacking conventional infrastructure. Moreover, community-based communication projects driven by mesh networks hold the promise of reducing digital inequality and fostering greater connectivity. Conclusion. Mesh networks offer a distributed and resilient communication infrastructure that transcends the limitations of centralized internet connections. The concept of an internet without the internet becomes especially significant in scenarios where traditional connectivity is disrupted or unavailable. In this article, we explored the fundamentals of mesh networks, their technical operation, real-world applications, and the advantages and challenges they present. While mesh networks provide promising solutions in emergencies, rural connectivity, military applications, and smart city implementations, they also face challenges regarding data speed, routing complexity, and security. As technology evolves, the opportunities presented by mesh networks could transform how we communicate and access information, offering a robust alternative to conventional internet infrastructures. In summary, mesh networks have the potential to play a pivotal role in the future digital landscape, enabling innovative communication methods and smart solutions for modern challenges. What are your thoughts on mesh networks and the concept of an internet without the internet? Share your opinions in the comments and join the discussion about the future of digital communication.